Identifying partial variations. Remember, when we talk about variations, we need to consider the slope. Slope is the vertical change divided by the horizontal change. We can also think of it as the change in the dependent variable divided by the change in the independent variable, or rise over run. And we remember rise is up and down like the sun, and run is across like a sprinter. You can also refer to it as a rate of change, a variable rate, or a constant of variation. Take a minute, pause the video, and look at all of these lines and see what they have in common. They all represent a direct variation, which means they're straight lines that pass through the origin, and they show that one variable is determined by multiplying a second variable by a constant. So a value is equal to a constant times a position number, or y equals mx, where m is the constant or the slope. Pause the video again and look at these lines. What do they all have in common? None of them pass through the origin. That makes them partial variations. They're straight lines that do not pass through the origin. You can still find the value of one variable by multiplying by a second variable, by multiplying by a constant. But if you look at them, you'll see that we moved all the points up or down 1 or 2 or 3. They change by a constant. So the equation varies slightly from that of a direct variation in that now we have the value equals the constant multiplied by the position number plus a different constant. Or we're going to call it y equals mx plus b. M is referred to as our slope, and b is referred to as our y-intercept. And remember, a y-intercept is the curve where the function crosses the y-axis. So the equation y equals mx plus b can be applied to both a direct variation and a partial variation. For a direct variation, the value of b is 0. For a partial variation, it's any number but 0. Consider the lines below. Consider the line y equals negative 2 over 3x plus 4. If we want to find the slope, we need to look at the equation and find the m. And m always incurs in front of the x. So the slope in this scenario is negative 2 over 3. The y-intercept is the number that hangs on at the end. And we need to take care of the sign in front and consider it as part of the y-intercept. The y-intercept here is positive 4, or the ordered pair 0, 4. Oh, there's a typo on the slope, guys. Sorry, the slope should have a negative sign in front of it. Is it a direct or a partial variation? It's got the form y equals mx, so it's going to be a straight line. And it's got a plus a constant at the end, so it needs to be a partial variation. Okay. Now if we look at the equation y equals negative 2x, the slope again is the number in front of x, so it's negative 2. There is no number at the end, so the y-intercept is 0. So because it's of the form y equals mx plus b, where the value of b is 0, we can say this is a direct variation.